Hi everyone, I'm Shubham Jawar. I'm a master teacher at Vedantu. We are discussing KVPY 2018 SX Part 1 Mathematics, and the question for this video is this. Let ln x denote the logarithm of x with respect to the base e. Let S be a set which is subset of set of all real values, be the set of all points where the function ln of x square minus 1 is well defined. That means S is the set of all values of x for which ln x square minus 1 is defined. Then the number of functions f having domain the set S and codomain all real values that are differentiable satisfy f prime x equal to ln x square minus 1 for all values of x belonging to the set S, and f of 2 equal to 0 is. So basically we have been asked to find number of functions whose domain is this capital S set, which each of which should be differentiable and satisfy this relation f prime x equal to ln of x square minus 1 for every x belonging to domain, and f of 2 is given to us as 0. So how many such functions would exist? Let's explore. Here first of all, what is the set S? All the values of x for which ln of x square minus 1 is well defined. So for this expression to be defined, x square minus 1 should be greater than 0. Or you may say, x plus 1 multiplied by x minus 1 should be greater than 0. And using VVCom method, you may say x belongs to minus infinity to minus 1 open union 1 open to infinity. Now f prime x is equal to ln x square minus 1. And ln x square minus 1 is valid for all x belonging to the set S. And that's how we have derived the set S. This is set S. Minus infinity to minus 1 open union 1 open to infinity. Now, as we solve this, differential equation, so to speak, we would get expressions or f of x in these two intervals, minus infinity to minus 1, 1 to infinity. And what we have is, f of 2 equal to 0, and 2 belongs to this interval. So that means the arbitrary constant corresponding to this interval we would be able to fix, we would be able to determine. However, what about the arbitrary constant related to this interval? Of course, this is the order 1 differential equation, so to speak. So there will be only one arbitrary constant. So for this interval, we would be able to fix the arbitrary constant, but not for this interval. That means f of x can be anything satisfying this condition in this interval, and that would lead to a family of functions, or you may say geometrically a family of curves, which in result would mean that f of x can be infinitely many such functions satisfying this differential equation, f of 2 being 0, and of course we are talking about this set S. My throat is very bad, please excuse me for that. So in case you have not got feel of it, let me show you through solution. So here x square minus 1 greater than 0 would mean this, which is very simple, which is very clear, which is very loud, which is not a big deal. We all would agree on that. F prime x is equal to ln x square minus 1. So as you integrate both sides, as you integrate with respect to x on both sides, left hand side you may say is f of x. It will be integral ln x square minus 1 dx. Now we are using integration by parts. So here I am taking this 1 as the second function and this as the first function. And as you integrate, you would essentially get this expression where c is the arbitrary constant. Now in case you are not convinced, let me solve it. 1 is the second function, so you get x times ln x square minus 1 minus integral, you would have x, and derivative of ln x square minus 1 would be x square minus 1, and you'll use chain rule, so 1 by x square minus 1 multiplied by 2x, so this is what it becomes. Now here let me do minus 2 plus 2. Now what about this expression? So this expression, excluding this minus sign, would essentially be this. Integral of 2 will be 2x with minus sign minus 2x. Integral of dx by x square minus 1, 2 times of that would be ln x minus 1 by x plus 1 mod you would put, and minus sign is also that. So c is the arbitrary constant. Now f of x will be this when x is less than minus 1, and it will be this when x is greater than 1. Now you may say this what's the difference? The difference is the possibility that the arbitrary constant may be different. Yeah. So whenever there are two, or there is union of two disjoint sets like this, then when we solve this differential equation, we essentially will have to break our function in these two parts when there are two such disjoint sets. So here C2 can be found out using f of 2 equal to 0, because this is f of x when x is greater than 1. So C2 can be uniquely determined. You put x to be 2 and f of 2 is 0, so you can find C2. But C1, arbitrary constant, can't be fixed based on given information. So as per given information, C1 can be any real value, so to speak. Hence, f of x overall can be infinitely many, there can be infinitely many such functions. So while applying initial conditions, so to speak, initial condition, f of 2 equal to 0, we will get only C2 but not C1. Hence, infinitely many functions are possible. D is the answer. Thanks for listening. Stay tuned for the next question.